Hi everyone, my name is Shri and I am from Arize, and I'm going to be doing basically a walkthrough of our meetup that we recently had that is for building and evaluating your TypeScript agents. So in this video, I will pretty much walk through just the basics of observability as well as evaluation. And then our actual demo and example of both of these will be using the Mastra agent framework, which is a TypeScript agent framework. And so we'll run through an example of that as well. But we can go ahead and just get started with kind of the basics themselves. So I think that it's kind of no small, like crazy suggestion or idea that agents tend to kind of go off script, right? And there's a lot of real examples of bad behavior out there that are trending on Twitter or trending on LinkedIn, or just you're going to notice it yourself as well. And so basically the idea is like, if I'm making an agent and I know that things like this can happen where my agent can go off script, how do I stop that from happening? And so basically the idea is that you'll kind of need observability as well as evals, to prevent this from happening in your system, whether that be through development, or even if you push it into production. And so if you're building an agent, we all know it's kind of messy, right? Like it's hard, it's messy. How do you keep track of everything that's happening? Working out of an Excel sheet is one suggestion. But the reality is that they just don't scale, right? It's hard for your collaboration, as well as it's just kind of slow to iterate on. Of if you were able to collect all of this data and put it in an Excel sheet and then look at them manually one by one, like that's definitely a suggestion, but the Excel sheet is just not scalable. And so this is kind of where we as Arize come to kind of help solve this issue itself. So we have two products. We have Arize AX as well as Arize Phoenix. Essentially, the idea is that if you were to use one of these products, you have one platform that takes you from development all the way to production. So you can iterate in dev, but you can monitor in production. And so the idea is that there's this consistent tracing as well as evaluation loop that you have on top of it. And so with that being said, today I'm going to be talking more so about Phoenix. So Phoenix is our open source observability platform. It's really easy to run anywhere. You can run it in a notebook, or we have Phoenix Cloud, which is like a hosted Phoenix version. You can run it through Docker or Kubernetes, or even just literally in your terminal, with like 2 steps and 2 lines. And so, yeah. And then also something important to note is that, it uses open telemetry traces. So, there's no such thing as being locked into one tool. In this example today, I will be talking about Mastra, as the agent framework that I'm using. But if you are manually creating your agents or your tools, or if you are using any sort of other popular agent framework or model provider or anything like that, we have a lot of native support for a bunch of them, where if you use our auto instrumenter, which I'll get to in a second, they'll automatically populate. Otherwise, it's all going to be kind of using open telemetry. So it'll be like in this like fixed standard, that is good across the industry. Ooh, did I skip a slide? No. Okay. So in terms of actually getting started, I'm going to talk a little bit about the auto instrumenters here. So Mastra so essentially, Open telemetry, which is like the industry-wide standard, we're using something called open inference, which is built on top of that. And the idea is that we have these auto instrumenters. Auto instrumenters basically just mean it's like plug and play tracing. So they basically will automatically capture your spans for like really common frameworks and tools. And so you don't need to necessarily manually trace your application. You don't have to go into your code and be like, this is a tool. This is an LLM call. This is my router call. You don't need to like essentially manually add all those things into your code because you're using Mastra. It basically will just reduce your setup time and kind of lets you get like your full visibility into your actual application with almost like 0 extra engineering effort. So that's kind of why we recommend you use our auto instrumenter there. And it's pretty simple. Like you just have to launch your instance of Phoenix. So like I said, either Phoenix Cloud, running it through your terminal, running it through Docker or Kubernetes or whatever it may be. Once you have that up, you can go ahead and drop this little code snippet into your actual instance itself. It just will set up basically like your Phoenix endpoint and your project name and stuff to connect your Mastra code example to like your Phoenix instance. And then this will also just automatically instrument your actual application as well. And so before I kind of jump into the demo, I wanted to do a little bit more of like the theoretical conceptual understanding of what everything that we've been talking about even is. So I think first we can start with observability, traces, and spans. I've used those words a little bit throughout this so far, but to actually like set in stone what it means, right? Observability, in short, is just going to be visibility into everything that's going on. When it comes to traces, right? Traces are going to be your whole run. So essentially every time you're invoking your agent or your application, that's going to be your entire run from start to finish is going to be a trace. And then a span essentially is like each step that your agent had done within that trace. So spans are going to make up your traces, and traces and spans together, right, is your observability into everything that's happening in your system. So here is what a trace is going to look like. For example, you can see that every single time, like if this is an agent application, right, every single time there is a query, right? And so there's one here in the middle that says, this is a test question, ? And then the output is, yes, this is a test question. And so the idea there is that I, as a user, maybe have invoked the agent by sending in this input, and then that is the output that I got back. And so because that's like a single turn of like me invoking the agent and the agent fulfilling its duties essentially and like giving me an answer, that is going to be your trace. And so this is what it'll look like inside the trace. It'll be a span. So this is actually a RAG system. It's not an agent system, but in the demo, you'll see what it looks like if it was an agent system. It's going to still look like very similar with this trace tree there, but the spans will just be different. So in this case, the spans are going to be the things like retrieve, embedding, synthesize, and LLM. It's essentially the steps that were taken from the time that I have given an input to me getting an output. So for an agent, it might be things like routers or tool calls or LLM calls, or even if it's multi-agent, like the start of another agent, kind of thing. So essentially the trace is like the entire chain of events that you are having done in your application itself. And so now a little bit more into how the traces are captured. I jumped the gun a little bit earlier by kind of explaining how this works, but essentially the idea is that like we are using OpenTelemetry, which is just like in general, we're using like open industry standards to actually get all of our data, our traces, our spans, etc. into Arize in a essentially like a good open industry standard way. So the stack there is going to be OpenTelemetry at the very bottom, which Open Inference is now built on top of OpenTelemetry. And then Phoenix is built on top of that. That actually shows you what the results are from OTel and Open Inference. And so essentially the idea here is that it is both kind of standardized as well as like extendable, right? And it kind of works across various ecosystems or various frameworks or tech stacks that you might be using in your application itself. So that was pretty much how much I had to say for observability, tracing, getting your data into Phoenix exactly. And so now I think it's like the next step of like, what are evals, right? So I keep saying observability and evals, observability and evals. What is evals? Evals are going to be your evaluations. So I think we get this question a lot of, isn't eval just a fancy word for a unit test? And I think it's interesting because, like, not really, right? It's interesting because like evals can't just be traditional unit tests because your LLMs behave probabilistically. So when you think of unit tests, right, you're expecting the same result every single time because you're giving it the same input every single time, or roughly the same input every single time. Because your LLMs behave probabilistically, you can't exactly put in all of your whatever your inputs might be for your unit test and expect to get the same result every single time, because your LLMs are not going to give you the same answer every single time, or your agent is not going to give you necessarily the same answer every single time. And so I think like reality of this is that when you think of like unit tests, right, or considering like eval should be unit tests, or the same thing, is kind of like a more old school software thinking kind of way, is how we would put it. People will oftentimes pitch you like, okay, if you have an AI like application, you just need to run unit tests and then you can ship them. Like as long as like your unit tests or your evals pass, you should ship them into production. But the reality of it is that they might work under a very small suite or large suite of like tests that you might have right now. But if you were to ask the LLM or the agent the same question in 10 minutes, it's not going to give you the exact same answer, where it might not necessarily pass your unit test in the exact same way. And so instead, the idea behind having evals of your AI application is that your iteration is actually going to be very continuous. It's not just going to be once, right? You can have evals that are like, like you might have some evals in your traces, in your spans, in your sessions, etc., right? But while you're in development and while you're in like your user testing, right, you should definitely have prompt replay. You should definitely have some level of evals, and you should definitely have tracing to, run those evals on. But when you put it into production, right, that's when you can run things like online evals. That's when you can have human annotations. That's when you can have like production replays. And so the idea there is that you really just need flexible eval approach to continuously iterate on your application and make it better over time. And so as we're talking about evals, I think it's important to kind of also talk about what should you run those evals on, or what should you evaluate. And I think that oftentimes when people come to me and talk to me about this, I tend to give them kind of the maybe the harsher answer of like, it's really dependent on what your application is, right? There are a couple different spans and parts of your application that you can evaluate, that most people would evaluate. So the different parts of your agent, right? But instead of just having like, you could run evals on just like success, like, okay, did this step work correctly? Yes or no, right? But you can also run evals on like more application specific things, which are totally up to you and what you might want to define. But regardless, there are just like parts of an agent that you will need to evaluate as you are just creating an agent, and every agent is going to have some part of this. So we're going to go through all of these. There's kind of 4 components to evaluate here. So it's going to be router, tools, path, and session. So going through each of these, your router correctness, right, is going to be critical, because if you have wrong routing, right, that can like cascade into different errors. And so you can use like span evals to catch this. And when I mean router, I mean like at the start of your agent kickoff, right? Is it going into the right next step? Even if it's not at the start of your agent kickoff, even if you have a router call somewhere else, if you have multi-agent systems, right, each of those agents might have a router as well. The idea here is just like, did it make the right choice? Or did I have to go back and reevaluate and kind of make a different choice for the actual correct next step or something like that? So that is something that is important to evaluate. That'll essentially help with like your throughput as well. Like if you need to latency as well, like how long is your agent taking to decide how to do something, right? What is like the time it takes from input to output is one part of it. And then the other part of it is just like, am I wasting money? Like, is the cost of it taking too long? So that's why routers are important, because you need to be able to get the best answer the fastest way, is the idea there. For tools, so with tools definitely like level up your agent, right? Tools are going to add both power, but they're also going to add a lot of risk into your actual agent. And so, you kind of need evals on each of these tool calls. The more tools that you have, the stronger your agent might be, but that also just means that there might be more failure modes. And so, there's a bunch of different tool calls that your agent could make, right? You could have a code generation or a data query or like a web search, right? Where it's like going out and calling all these APIs. Regardless of what your tools might be that your agent is using, it's really important to make sure that your tools are actually bringing back in correct information or valid information into like your agent workflow here to actually get you through getting the right answer, because garbage in is garbage out, right? If your tools are coming back and giving you garbage, right, and that's going to lead to the next step, then you know that it's maybe not the best thing that's happening, and that's why you should be able to identify that your tools are actually working correctly. And now kind of moving into our next component to evaluate. So we went over kind of span evals, and now we're going to look at trace evals, which is going to be our decision path. So this is basically going to mean that we want to evaluate our reasoning path, right? So a trace eval basically means that you now have the order of all of your steps as well as the logic of all of your steps. And so this is basically going to be one that helps kind of catch maybe bad trajectories. Something that might help is like, now that essentially your evaluator will have like, okay, this was all of the steps that were done. This is the order in which they were done. This is the input and output of everything that was done, because it's just like a lot more data that your evaluator will now have. It kind of helps you catch these like, exactly like what I said, like bad trajectories, right? It'll basically be able to figure out and see like, is there a more optimized way that I could have done this? Did I have to recall a step multiple times or something like that? And that will basically kind of tell you if there's something in your logic. So maybe something, again, back related to your router, that maybe should have changed in your application itself. And then now that we did trace evals, like another step above that is going to be session evals. So the idea behind session evals is, if you're having like a chatbot or some sort of agent that it's multi-turn, right? How do you actually run an evaluation on the entire session itself? And so this is like even more data, right? Than like our trace evals, because now you have multiple traces within that entire session. And so some things that like you might want to consider when you're doing like a session eval, right, is like tone, repetition, context retention, as well as like full conversation coherence, right? I think a really good example of thinking about this is like, if you are only looking at the trace, right, you might have like the trace might be right? Like it might have reached its goal within the trace, but in the context of the entire conversation, did the agent misinterpret something that the user had said, or did it forget some sort of context that the user had given early on in the conversation? And so that's kind of taking it a step further by evaluating our entire full session. So we've talked about evals a bunch, and like different kinds of evals, and why you should run evals, and how you should, and what evals you should run. But the thing that we haven't covered yet is how to actually run your evals. So there's actually two kinds. You can do both offline as well as online evals, which I will get to in a second. But while we're on the topic of still talking about types of evals, right? Like, we talked about what you should evaluate. In terms of how you should evaluate them, is that evals kind of have like three main types. There's code, human, as well as LLM. And so you can use all three, again, depending on what your use case or what your need is. So for code evals, right, we have to kind of break down into both traditional as well as like heuristic ones. So traditional are kind of like exact match, regex or numeric checks. So things like, if you just wanted to run an eval on like, does this SQL query return 15 rows, right? That is something that could be a more traditional code-based eval that you don't necessarily need like an LLM or like human feedback to go ahead and do. For heuristic ones, it's going to be more like rule-based scoring, right? So like, does this response contain both a date as well as a location or something like that? As like an example of like rule-based scoring. The next kind of set of evals that we have is human evals. And so we have, that kind of breaks up into feedback and then annotations. So feedback is like, just like the traditional, like thumbs up, thumbs down rating. Like, was this answer helpful? Yes or no? And then for annotations, it's going to be more like structured labeling. So it's going to be like, if a human marks like, oh, this is hallucination, or this is off topic, or this is factual, or something like that, is basically going to be like annotation based evals. And then we have the entire suite of LLM evals. So LLM evals, like, or LLM as a judge, is like what they're more traditionally known as. I think are a lot more popular right now. But they also kind of aim to solve these two kind of problems. That's pairwise as well as direct scoring. So pairwise is basically if model compares like an A versus a B answer. So like, which answer is more accurate or clear, right? If I'm essentially judging on two kind of main ideas here, and I want to test like two options against each other, then you would use an LLM to be able to kind of like break down those answers and understand them, and then output like a response that will be useful in this case. or you have direct scoring. Basically like a model gives like a yes or a no, or like a 0 or a 1 or something like that. Is this response like factually correct? Score at 0 or 1 or something like that, where it's like reading the answer, it's like understanding it. You are hopefully, you should pass in metrics about like what does correct or incorrect mean. It kind of understands, right, like what correct or incorrect means. It comes up with that answer and then it gives it a score 0 or 1 accordingly, or something like that, is the idea behind the direct scoring LLM based evals. So I think this chart is kind of like somewhat encompassing of the different kinds of evals that you can run. And so, yeah. I think a key point that I really wanted to focus on here is that reliable agents aren't discovered. They are going to be engineered through your system. So the key message here is that reliability is engineered, right? You want to have these systems in place, these systems meaning evals, over just like general vibes of like, okay, this is going to do well, is kind of the idea behind what we're trying to say here. And in order to kind of engineer these, you need evals, is the main point. And so kind of the best way to actually get these evals to run is really simple. If you can just run a simple evaluation that is kind of built up like this. You have an eval model, right? And then you have a prompt template. So these are two things that you're going to need to define. You can choose any model realistically. I think there's a little bit of research that's being done out there of like what is the best eval model, right? Like if you want to use a reasoning model, totally valid. I think that reasoning models are better at certain eval tasks. And then you have your prompt template, right? You have to actually define who your judge LLM that you have, exactly what you want done, right? Like what are you running your eval on, right? What data are you going to pass into your judge that it needs to look at, and then like figure out what the response is going to be. So if you define these two things, which is going to be your model as well as your prompt template, one of them is a little bit harder than the other, the prompt template being a little bit more complex in just what model you're going to use. You could take these, and then essentially the idea is that you give your model a prompt, and then you also give it your like AI app. So like essentially the traces or your data set or like whatever it is that you're passing in. Then your LLM model will actually go ahead and output your response, which is going to be your eval itself, is the idea there. So moving on, this is kind of the anatomy of your evaluation. So this is exactly what we had just said. You need prompt, model, and data, right? If that's the stuff that you put into your evaluation, put in meaning like that's the stuff that you are creating for your evaluation, then your output will be things like your label, your score, as well as your explanation. I want to pause and talk really quickly about the explanation and how important and useful of an artifact that it will be when you run your evals. Labels and scores are great. Like they are very good parts of your eval that you should have. Of like your scores will give you like a really quick metric of like this is how well XYZ, whatever it might be. Like if you're running like a tool eval or something, right? Like this is how well this tool is working. 9 out of 10 times it's working correctly. So that's great. Like you have your score, that gives you that metric. You have your label for you to really quickly see and be like, okay, all of these are incorrect. I'm going to take these and add them to a data set and go iterate on them. That's also a good part of your eval. The explanation though is I think probably one of the most helpful for the actual next step, which is going to be like your iteration. So in your prompt template, right, you should have something that's like, you are a judge on checking how well this tool works, or you are like an expert at checking how well this tool works. As like the very first thing, you pass in your data, you explain what correct and incorrect is, you explain the scoring, like correct means 1, incorrect means 0. And then at the very bottom, you should say, explain your answer, like create your explanation for how you came up with correct and 1 or whatever, your label and your score. And also return that. So as the result of your evaluation, you're getting 3 things per every input that you give, which is going to be your label, score, and explanation. The explanation is going to be really good because it'll then say like, oh, I found this to be incorrect because it messed up on like this step or something like that, where it'll basically create some sort of like reasoning for why it came up with like the fact that it was incorrect. And now looking at those, right, looking at this like world-class, like first-class artifact that you got from your evaluation, you can kind of come to the understanding of like, okay, like every single time that my eval has given me an incorrect like label for this input, it's coming up with this exact same response. Maybe I need to go back and tweak this part of my tool creation, or I need to tweak, honestly, my eval, because maybe your eval is consistently finding the same error that you don't necessarily care about. That's something that you can go back and tweak your eval prompt about, actually. So an explanation is just like a really good way for you to essentially get more information, essentially kind of like gets like a tip maybe about what you need to iterate on and change in your entire application itself. And so, like I said, there's kind of two ways that you can run evals here. You can run offline evals or you can run online evals. So offline evals is going to be kind of better for like, I don't know, like it's just kind of part of like the CI/CD pipeline. It's good for both like regression testing as well as just like dev workflows. So this is actually what I'm going to show with Phoenix today in our demo. But the idea is that you have like your application running, right? You have like your evals that you're setting up in your code. So in your code base, I have my judge created as well as my prompt created. Once I get like my traces, or if you're wanting to run your evals on a data set, once I have those, I can pull those back down into code, bring my data back down into my code, and then run my evals locally. And then if I wanted to look at them in Phoenix or whatever, I can push them back up, is basically the idea there. This is going to be offline. Online, on the other hand, is like online evals on like live data or live traffic, right? So it's meant for more like continuous monitoring. And it'll add the evals like to the spans basically as they come in. And so online evals are really helpful for, especially if you have some like your application in production and you want to be able to like create monitors or like something specific around how well your evals are working, is how kind of the online evals work. So online evals are available in AX if you wanted to try that out. Like I said, it's really helpful. You can still use this during like the dev workflow as well, but it's just going to be like slightly different use cases, whichever works best for what you are building exactly. And then I briefly want to touch upon this like advanced topics part. We kind of already went over this, but there's kind of these session, trace, and agent level evals. And so the idea here kind of being that like you have these different levels of evaluation. So I would always recommend that you start with like a span eval, right? So things like if you have a router call, like if you have a router call, what is the best tool call to make? And then did it choose that right tool call is like an example, right? And then you have trace evals, which is going to be like, is this the right order of tool calls? Because now it has all of the data. And it's now able to see everything in succession to see like what happened first, what happened second. Was that correct? And then the third kind of level to this is the session evals, right? Throughout this entire conversation, was it coherent? Was the same tone of voice used? Was my goal achieved? Something like that. And then the idea here is like once you have these different levels of evals, right, you can kind of put them together to kind of build this story and like this composite eval almost of like, okay, overall, right, what parts of my application are not doing well? What parts do I need to iterate on? It just takes it a step further, basically, of it not only shows you where your application is lacking, right, or where it like did throw back to the beginning of this where it gave like a bad response or something. Like it's not just showing those in like a bright red light, but it might even show you where you need to improve and how to make sure that that doesn't happen consistently over time, multiple times is the idea there. So that pretty much will reach us to our demo. So we can go ahead and actually see this in action itself. So now we're back in our code, and I showed this on one of the slides, but I wanted to show it again really quickly of just basically how to get this observability part up and running in your master agent if you already have one. So in your indexed file, right, .TypeScript, you basically just need to set this observability section that will take in like your project name as well as like your API key and your endpoint and your project name. In my environment file, I have my OpenAI API key set above, which I'm not going to show right now. And then I also have my Phoenix endpoint as well as my Phoenix like host basically in my project name. It's localhost because I'm choosing to run this locally. So in my terminal, I have Arize Phoenix installed. So I have just run Phoenix serve, and now I have Phoenix running in the background. And so this is going to be my endpoint, but if you're using Phoenix Cloud, it's going to be slightly different. It's going to be your space name, or your space endpoint is basically the difference. But other than that, the rest of my agent is still going to stay the same. Nothing else has really changed in any of like my workflow or my tools or like anything like that. It's all just going to, like, the only thing that I need to add to actually set up like my observability here is going to be this one, little chunk and section in like my indexed script. So I have my Mastra instance kind of up and running as well, and I can ask it a quick question like, what's the weather? I didn't specify a location, so okay, yeah, there we go. It asked me for a location. I can just say Austin, Texas, and then we can go ahead and see what it does there. But while this is basically running, I can go ahead and go through Phoenix again, refresh, click on this, and we can actually see that I've recently asked it, right, like, what's the weather? And we have the trace already in here where it's going to basically go through and kind of, there's no tools that it had used here, so there's nothing to do here, but it actually has like all the steps that it took to come up with our answer. So when I asked it Austin, Texas, you can see that I actually did use a tool called Weather Tool to get the input as well as the output. Now back into our code, I'm going to run us through some of our evals that we are going to run. So I have a couple that are preset here. I have a tool correctness prompt, or tool correctness eval, an agent goal completion eval, a fetch weather step, plan activities, and activity planning quality prompt. So essentially for all of the different tools that it is like gonna run, I have an eval set for them, as well as like a goal completion one that is going to be like a trace level eval that's overarching. So the way to actually do this is once I have set my tools here, and my prompts here, as well as my model. So my model judge that I'm going to be using is GPT-4o Mini. I have my project name, so essentially like where my data is going to come from. My tool names, the workflow steps, whatever. And now I have my judge prompts outlined here. The next steps here are going to be to actually get down the data. We're going to have to massage the data just a little bit, like extracting the input and the output from the span so that that's just like the only information we have and there's no other metadata attached, just to kind of make it a little bit easier to pass in to all of our evaluators that we are going to run. And then once we get all of that data, this is essentially how you're going to do it. So to actually evaluate it, right, you're going to create your eval first. So this is the tool correctness one. You're going to name your evaluator. You're going to pass in your model as well as like your rails. So like the choices basically of your correct or incorrect, as well as your scores. So 1 and 0, and then your actual prompt template itself. And then since this is our evaluator here, we can actually scroll down and it'll actually evaluate down here based off of our input and output that we are passing in to our evaluator. And then it'll take the results and basically just push it back up into Phoenix here, into our project. So I'm also just having it kind of output some like really quick metrics here. That'll kind of just be helpful for like at a quick rate. Like if we want to see like, okay, like is this tool passing enough for me to go not worry about it or iterate on it? You can also run stuff like that, but this is totally optional and not related to our eval set working. And the way that we actually push it back into Phoenix is by this one function here, which is log span annotations. You're basically just going to log your evaluation results as an annotation and then push it back up into Phoenix. So we're going to do that for essentially the other evaluations that we also want to run here. And then that is going to be pretty much it. So I went ahead and ran just talked to the agent a little bit more to give us a little bit more data. So for example, I asked it to give me the temperature for San Francisco right now in degrees Fahrenheit, which it gave me. And so yeah, so now we have about 7 traces here worth of data. Going back into our code, all I have to do is just this npm run eval since we have our evals run. And so what it's basically going to do is take the data, bring it down, create these evaluators, run these evaluators, get like all of that, push the data back into like essentially like our data that we have brought down, right? And then because of this log annotations, it's going to push all of those span annotations up again. So when we go to Phoenix and refresh, we should be able to see all of our evals there once this is done running. Now back in Phoenix, we can see our evaluation results right here. So this is our same project that we had. And now we just have all of these annotations as well as these like quick pie graphs here that kind of show our results. So yeah, so we can see, clicking through this really quickly, we can see that our goal completion failed on 2 of our traces. So if I want to figure out why, I can go in and actually click on my annotations and see like, okay, yeah, so the label was incomplete, the score was 0, and the explanation was that the agent did not provide specific activity recommendations based on the weather in Seattle, nor did it fetch the weather information needed to do so. And now if I'm like, what is it saying? I can go back here and look at my actual query again and remind myself what happened of, okay, yeah, so I asked it, what activity should I do in Seattle based on the weather? And it did not provide me the weather or the activity, so it did not achieve its goal. So I know that now I need to probably go back into my logic of my code and maybe actually add in something that's like, if there's no weather, right, to go actually find that weather first is kind of the idea. So this one again is the same thing. Did not provide any weather information and instead asked for like a specific location. So maybe there's some sort of fallback that we should fall back to, right? When that information is not passed in to the input. And so that is pretty much how these evaluations are going to work. If you go to one that actually has a tool call, we can see that this one was correct. And then, yeah, that's pretty much it. So from this, I think like a couple of next steps that you could take would actually be, oh yeah, all of them were correct. So none of them are going to be incorrect. A next step that you could take from here is you can actually filter on maybe just the goal completion ones that failed. So you can filter on them or manually just select them. And then you can add them into a new data set that you might have. And then once you have them into a new data set, now you can run experiments of if you make a tweak or a change into your application and you want to rerun using these same queries, if your output is going to be the same as this like reference output, which is your output right now, or if your new output is going to be any better, you can run evals on that, etc. So that is kind of an idea of how this workflow can continue on. And that was pretty much it for our demo that we had. So we went over kind of how to set up tracing, how to run evals, as well as like your next steps of potentially what you should do once you have that eval data to actually help iterate and improve your application itself. You can look at them manually one by one, but if you were to have, we only had 7 spans and traces, but if you had like 15 or 30 or a larger number and you didn't want to click through manually, you can essentially just filter for like your failed cases and then figure out how to iterate from there. So that's pretty much all I had today. Thank you so much for watching. If you have any questions at all, you can connect with me on any of my socials, as well as you can join our Slack community as well. So yeah, that is pretty much it. I will see everyone in the next one.